Today we'll be looking uh, to solve other questions. So we solved two sum earlier, and today we will try solving some other question, probably this one, longest substring without repeating characters. Okay, lowest substring without, longest substring without repeating characters. Okay, the internet is a little bit slow, so sorry about that. Okay, and along the way we will be following these rules, so we can read them, basically read question, clarify understanding of inputs. This is important. Input, outputs, add the side effects, and ask questions. Assumptions, we can take some assumptions, uh, reasonable assumptions, and then we should not just go into coding. We should first go through an example, ensure our understanding of the problem, and then spend some time spend some time to understand the problem. Actually, then we should come up with an algorithm, and which could be a brute force one, but should uh, actually complete the problem, solve the problem, and then we can uh, improve on it, and then discuss the time and complexity of this problem. And we also state any edge cases if we found any. If generally questions have state edge cases. So okay, this is the problem that we solved earlier yesterday. Let's go for this. Add two numbers, longer substring without repeating gaps. Okay, there's an add two numbers as well. Roman to integer. Is that the same list? I'm not sure. Let's check. Add two numbers is in this list. Add two. Add is only once. Okay, then where is this coming from? I don't know. This is the same list or different. Come on. This list is all this list are same or not? Add two numbers, longest substring without repeating characters. Longest substring without repeating, longest palindromic substring, longest palindromic median of two sorted array. Median. Okay, this list is different from the list that we have here. I don't know how this list is generated. We can go through this list as well. Let's go through this list then. So add two numbers. Add two numbers. Okay, cool. So let's first read the question. So the question is, you're given a non-empty linked list representing two non-negative numbers. So first the thing is non-negative numbers. The digits are stored in reverse orders and each of their nodes contain a single digit. Okay, add the two numbers and return it as a linked list. You may assume that the two numbers do not contain any leading zeros except the number 0 itself. Okay, so a lot of corner cases are already handled by the input only. So if you see, they're saying that so if we are adding 3 4 2 and 4 6 5, so the number will be 2 4 and 3. Yes, 2 4 and 3, and the linked list and the same is this 5 6 and 4, and then we need to return, and the output should be 704, which means actually 807. Okay, so we can add 5 and 2 to get 7, then we can add 4 and 6. Now 4 and 6 will be 10, so we'll get 0 and we'll get 1 as the carry. So then we can add that to 3 and 4, which is 7 plus 1, the carry 1 is 8. Now one thing that you should remember, that I should remember as well, that while adding two numbers in linked list, it should be in the reverse order so that it's easy for us to do, because if it's not, then so see, if this is in opposite order, then we can actually traverse the list in the same order. So that's one case. And this, we are given the linked lists data. So val is the data and next is the pointer in that, and we have a constructor in that. Okay, so let's again write points on the questions that I have understand. The first is it's non-empty, empty. So that means given two non-empty lists, that means that L1 and L2 here will not be null. But let's write an edge case. We should not write, let's write just L1. We should not write code here right now. L1 and L2 are non-null. This is one thing that is given to us. Then these are representing two non-negative numbers, that is numbers are non-negative. Numbers stored are non are positive only, you can say positive only, and 0 is inclusive 0 is neither positive nor negative, but 0 is inclusive in this case, because here it says except the number 0 itself. So the digits are stored in reverse order, that is one thing. You can say reverse order, and then each of their nodes contains a single digit. This is also important, that each node contains a single digit. This node has a single digit of the number. Okay. Then add these two numbers. We need to add this number and return it in a linked list. So this is, so if you talk about this rule, so we have got the question, and now if you want to actually specify where this is input, output, and the effects, so you can see that input will be two linked lists, and the output that we need to send is one linked list, result linked list, linked list. Okay, so, and the side effects are, what is the side effect? I think edge cases will be just L1 L2 could be null, which says that it will not be null, and yeah, this is the only edge case. So if it's not, then what we need to do is just add them. So if you see here, let's copy from here. Okay, so we need to add this with this, so that means we will get this 708. Okay, 708 as the answer, which corresponds to 807 if we reverse it. So reversing is all handled by the code on the question as only. What we are, the idea behind this question is just we need to somehow add this strings. So the approach will be simple, as in it will be an O of an approach, that is my one pointer will be pointing to 2, and okay, let me write these pointers in my copy: 2, 4, 3, 5, 6, and 4. So okay, now my one of the pointer will be pointing to 2 and another pointer will be pointing to 5. Okay, now what I will do is I will also create another uh, linked list. So I will another create. So first the pointer at 2 and the pointer at 5, I will add these values, so it will give me a value 7. So I will create a linked list, and then I will add this add 7 to this linked list. Okay, so I don't think we need to create a linked list. What do we, there is a list node, it's given. So we can actually, we need to return the head of this string, basically 7808. So we need to return this node 7 node. So we might need to implement the logic for inserting into a linked list, because we would be inserting the values that we add. So in case of 2 and 5, we will add 7 to that linked list, insert that 7, and after that 7 we will increase our pointers like to 4 and 6. Now we will again add, and we will again, so the value will which we get is 10. So out of 10 we get the mod, or 10 mod 10, which will be 0. So, and the remainder and if we divide it, so the remainder 10 mod 10 will be our value. So 10 mod 10 is 0. So this will be the value that we need to insert into the resulting linked list. So 7 0, and now the remainder that we got, which is 10 divided by 10, the carry that we get 10 divided by 10 will be used for the next summation, which is 3 and 4. So in case of 3 and 4, we get the sum of 7 plus the carry that we have is 1, so the sum we get is 8, and then we are done as both our pointer reach to null. After 3 and 4, both the pointer from list A, list L1 and list L2 reach to null, and then we are done. Okay, now suppose this is the case where these lists are of say same length, but what if the lists are of not a similar length? So suppose this list is like 2, there's one more element in this, and this list does not have. So what does this mean? This means the list is now, number is now 2 3 4 2 as it's in reverse, and the number this is in 465. Okay, so the sum should come to be, let's add this, 465 2807. Sum should come like 2807. Yes. Okay, so now we will add this 7, we will add this 10, and we will get add this 0. Now you see here we do not have any number here, so sum is all done here. After this only this will come 2, only 2 will come to, it's 2807. Okay, correct. Now there's another case. Suppose the last element, these two elements generate, the length of the elements are same, but the last element generates and carry. Okay, so if you see another case, in this case 2 4 3, and let's remove this and say this, it's instead of 3 it was like 7, and instead of 4 it was like, again since 7 14, suppose, let it be 4 as well. So now the sum of these two, 2 and 5 is 7, 4 6 is 0, and 7 and 4 is 8. Okay, no, sorry, 7 and 4 is 11, 7 3 is 10, 7 4 is 11. So now we get 1 as here, 1 as the sum, and then the remainder will be 1, and they will create another node. We'll have to create another node for accommodating this carry, as there are no other values that we can add. So in this case the sum becomes 1107, and here also it becomes, let me update this, 2807. Okay, so these are the cases when the lengths are same. Then I don't there are two cases that the last that any value can have a carry for the next element. If it is, then we have to add, but if there is not carry, then we would need to add a new node. The only thing that I'm thinking of is not traversing, is adding. So the thing is, we need to traverse the linked list on L1 and L2, or I can just name linked list A and B to be better. Okay, so we'll traverse through A and B till they are not null, and when either of them is null, then we will need to just traverse another list, like the one which is not empty. Okay, but while we are on this, we need to create a, okay, so we can do is like something easy as simple as we create a empty node, empty linked list, and then we have a pointer on to that list, and we will also have a, so suppose what I'm saying is basically this case. So first we create a linked list with empty linked list basically. Okay, so let's say the data is 0, suppose, for now, and then we have a pointer to this 0, and as soon as we add, we will add the value. Suppose for this case, so we will add 7, this case is answer, we will add 7 to this pointer, and then we will also have a pointer to this. So we will have a pointer to the head, and we will pointer to this value as well. Then when we again add, we will add the tail. So this is the head, this is the tail. So we'll again update the tail and have the tail point to 0. Then we again update the tail and we have add 1 to the tail. Then we again update the tail and we add 1 to the tail. So these all elements are added. Now we can return is just the head dot next, which is this all elements. We could somehow, there would be a way we can, without this also we can do this. So I think I will now code. The approach is that I'll be traversing through both of array till they are not null, and once they either of them becomes null, we will be traversing them separately. So that will be something like of the merge sort, merge two arrays kind. So okay, so let's have a edge case which is not even required. But have it if a equals to null or b equals to null, then we can return just return null. Okay, now I can traverse this line. So while our a is not equal to null, so we can have a pointer. We had okay, a is a pointer that will we will be using to traverse this list, and b is the pointer that will be using to traverse this list. So a is not equal to null, and b is also not equal to null. Okay, if this is true, then we will traverse this and we will have to increment both of them. So a is equals to a dot next, this is next, okay, and b is equals to b dot next. Okay, this is the traversing part is done. Now the logic is, so these are not null. Basically I'm now at 2 and 3, so we can do is basically add these values. So and sum, we can say a dot val plus b dot val. Okay, b dot val. Okay, so needs these to sum. We could have a smaller data type, as these will be two single only a single value, so the sum will not be going out of suppose short, so we could use short. So integer data types are if you remember, integer data types we can are int, long, short, and then byte. Is that correct? Short is correct, I'm not sure. So int data, I can search data types of Java and data type Java. Okay, byte, my instrument is not working. Integer data Java. Okay, some issue with the internet. This data types Java. Okay, so let's look at the image. So till then let's solve this question. Okay, so but let's take it as int only. Now we have the sum. Now we want to insert the sum into the linked list that we want to send. So let's create a linked list that we would like to send. So list node is the type of the linked list. So list node and equals to new list node. Okay, now I've created a list node of the, so I'm creating a head node. Basically this head node will have, suppose that default value of, so we have given a constructor to have value, so let's do it -1. Okay, now I have a head. So what I will be after this I need to attach this. Okay, and I can have a head and then I can have a tail, because tail will also be pointing to this list node tail equals to head. Basically tail will also be pointing to the same head. So 0, it's -1. That's instead of 0 I'm using -1. So -1 is the head as well as the tail. Now I will be adding this element to my tail. So I will say tail I'll create a first list node, and then so like create me a, like let's create a list node equals to new list node of type list node, and the value is will be sum. Okay, now one thing also is there that sum could go beyond one digit, because suppose 9 or 9, so it will be 18. So we would have to have a carry as well as the remainder. So for that we can do is we have a global variable and carry, let's carry equals to 0. Okay, that because we need to add the carry, and uh, remainder equals to 0. Okay, so remainder I think we don't need to initialize. So what we will do is after getting the sum, we will sum will actually be this value of a plus b plus the carry as well, because it might be the case that some carry is already remaining. Okay, so we will have the sum. Suppose in this example like 4 6, so in this case 3 4 was there, but we had a carry from this, so 3 4 plus the carry that we have, this we add the carry, and after this we need to reset carry actually. So we can reset carry to 0, and then now we can again calculate the carry and remaining. So the remainder will be basically whatever the sum is, then we take the its mod by 10. So suppose the sum will be, if the sum is 11, and then if I take mod with 10, so it will give you the last value. Okay, so it will be 1. Let's take 13 as an example, so it will be 13. But if you divide 13 by 10, you will get 1.3, that is it will give you first value. You can say 13 mod 10, you will get 3, this is last example, and 13 divided by 10, you will get the first value. Okay, 1.3 as 0.3 will be ignored. Okay, so this is the remainder, and to again calculate the carry, if there is any, so you can have sum divided by 10. Okay, you will not have a carry for the examples. Suppose if we have suppose 7, so 7 and you divide it by 10, it will be 0.7. So 0.7 is just 0 in programming. Okay, so we calculated our remainders and carry, then we will have our node with the remainder, and carry is now updated. Now this carry is updated, and we will have our remainder. We create a node with the remainder. Now we need to add this node to the tail of this. Okay, so tail dot next equals, now the tail dot next value will be our node, and also now tail equals to tail dot next, we need to increment the tail as well, dot next. So this should increment the tail. Okay, now this solves the question when this is the case. Okay, but what if there is, these are the case. Now if suppose one of the list ends, so now we will have to, we just traverse that list. So if a is not null, if while a is not equal to null, we will traverse a, and suppose if b does not end, so while b is not equal to null, we will traverse b. Now what we will do is kind of very similar to this. I think we could have done this in the same logic, let me think. So if okay, what you can do is okay, let me have this here. I think you don't need this, there's a better way to do this. So suppose rather than we are here we were going if both a and b are not null, so let's go, well, a or b, we have a value in either of them, both of them are not null, either of them is non null. So now to calculate sum we cannot use this, because now some of them could be null. Suppose a null, then it will give you a null pointer exception. So we have a sum. Okay, then what we can do is, let's the sum equals to 0. Now if we have a is not null, if a is not equal to null, then we can say sum is equals to sum plus equals, basically sum is equals to sum plus the value of a dot val. Okay, and if we have, so this will move the, so let's, even we can say carry, because carry is already 0. If it is not, then it will be calculated. So this, we can replace this whole thing with these two ifs. So if b is not equal to null, then we can say uh, sum plus equals to b dot val. Okay, and then we have, so now we have calculated a sum is a carry, and then sum we are adding a if there's a, and if we are adding b if there's b, and after that we set the carry to 0, and we calculate the remainder of the sum, and we calculate the carry of the sum, and we then add a node to the last tail of the node, and then we again increment the total. So this will actually handle both these cases. How? So let's see, 2 4 3 and 2. So in this case 2 5 will work as a sample, as we have both 2 and 5 are not null in this case of, as we have 2 and 5, so both are not null. We'll go inside them, we will get the sum as, because carry is 0, sum as 0, and then, so then we will get a is not null, b is not null, so 2 and 5 will add it to the sum, so 2 5 and the carry is 0, and then we can calculate the remainder in the carry, and we will have a, we'll create a node out of that. Okay, and then we will add this node to the tail of next of the tail, which is 7, and now we will again update our tail. So now tail will point to 7. Earlier it was pointing to -1, now it points to 7, and we can then update our, then let's check if we returns. So return, we need to return head. If we return the head, not head, we need to return head dot next. Okay, it should, let's check, we can copy this code if something goes wrong.